Alright, we're going to look at manipulating formulas. Now, formulas are kind of, I guess the best way we can say is we like naming things in mathematics to represent things. And so we tend to use variables to represent other things. And there's a big history of why x is important. And then after that, people used x, y, and z for alphabetical order. Sometimes u, v, and w if they needed three things because it came before x, y, and z. It was the first things before that. And also naming things that kind of made sense for what we were talking about. So if I were talking about Fahrenheit, I'd label my variable F. If we're talking about Celsius, I'd label my variable C. And so we have these things that we want to use to talk about other things. And they can take on any number. They're like empty boxes waiting for a number to fall into them. So they look like equations, they have an equal sign, but they take on deeper meaning, or not deeper meaning, but multiple meanings based on what we throw into them. So what we're going to do is we're going to look at a particular formula you're going to see. I'm going to use the variable x with a bar over it. And that means the average value, the average value. So we read it as x bar, but we're going to talk about it as the average value a lot. Well, we have a formula for an average, so I'm going to talk about how we calculate an average and turn it into a formula. And so I want to talk about the average. I'm going to put x bar. And that's going to be my shorthand to say I'm talking about the average of something. And so every time I write down a formula, I don't have to write down the average value. This becomes its name, the average value. Now, when I do an average, let's say test scores, I get a 75 on my first exam, an 80 on my second, and a 70 on my third. Well, what is my average? The way we calculate an average is I add the three of these up. So 5, 14, 225. And there were three of them, so the average I divide by 3. So 3 goes into 22 7 times. And my average overall was a 75. And so the average of this is 75. And I found it by adding everything up and dividing by the number of things. Well, what if I don't know how many exams I had? I don't know I'm going to divide by 3, and I don't know all my scores yet. Or you're a crazy professor like me and you need a formula to keep track of it. So we're going to use that from the previous video, the sum. And I can sum all of my scores and divide by the total number of them. And so I've now written something where I don't have to write it in words. If I were to say this in words, I'd say the average of my test scores is the sum of all the scores divided by the total number of scores. That's, in English, what I'm doing. What I do is I use these things, these symbols, to say all this. So if x bar is the average of my variable x, which is my scores, the equal sign takes place of is, so I've now said the average of my test scores is the sum of my scores divided by the total number of scores. And so I'm using these letters to keep track of things. And I'm keeping track of things that I don't even know what they are yet. Right? I could use this formula for each and every one of your test scores. We haven't taken any tests yet. But as we take them, I can put them in a bucket, and test number 1, you got a 95. Test number 2, you got a 90. Test number 3, you got a 93. Test number 4, you got a 90 again. And I can go, well, here, my formula says add up all of these and divide by how many things I have. And so the formula becomes a way of storing things. And we store them with variables. Well, there's another way we can talk about formulas, or other things we can do with formulas. We can manipulate them so that we can talk about different things. So, for example, if I have a formula that says some variable m is equal to the sum of two other variables divided by 2. This tells me what my formula is. And if I knew A and B, let's say A and B was 4 for A and B was 3, I can figure out what M is. Because I can come over and I can drop A into here, and I can drop B into here. And so my M would be, well, 4 takes place of A, 3 takes place of B. I get 7 divided by 2, or 3.5. But I might not always know A and B, or I might be waiting until time comes along that I can measure A and B. This I carry with me coming through. But let's say I don't know A and B, but someone's going to give me M and B. I need to find A. And the nice thing about formulas are, even when we don't know what's going in these boxes, we can unwind them and manipulate them. And what I tend to say is it's like an onion, and you're peeling back different layers. And if your order of operations was PEMDAS, and you do things from the top down, when you peel back your layers, you go in the opposite direction. Do your additions and subtractions, your multiplication and divisions. But a thing we have to watch is when we write fractions like this, it's saying whatever A plus B is divided by 2. So if I want to go backwards, and I want to go around, and I want A all on its own, I've got to get rid of everything that's around A. So what I want to do here is I want to scroll down. I'm going to rewrite this here. And so my job is to get rid of everything that's around A so I can get A on its own. Now, an equal sign is saying the two sides are equal. The left-hand side is equal to the right-hand side. And if I had two numbers, 4 equal to 4, right, that's a truth. I don't have a variable. But if I did something to this side, let's say I multiplied it by 2, well, to keep that equal true, I have to multiply the other side by 2. Or if I started with 4, I'll scratch that one out, and I add 1 to it, to keep the other side true, I have to add 1 to it. And so the rule that you'll hear me sometimes jump up and down and shout is, whatever you do to one side, you have to do to the other. Because it keeps the two sides equal, right? If we have a number and I change one side to keep the equal sign of the numbers together, I have to change the other. Well, even if I have variables, I'm saying these things have the same value. So whatever I do to one side, I have to do to the other. Well, I want to get rid of this divide by 2. So to get rid of a divide by 2, I'm going to go down, change my color, I'll do a bright red. I'll go from, oops, I did hit yellow instead of red. Oh well, yellow will work. It's more of a greenish yellow. I want to multiply, right? If this is a division, to undo a division, I'm going to multiply by 2. But whatever I do to one side, I do to the other. And so 2m is equal, well, if this is upstairs and this is downstairs, they did undo each other, and I have a plus b. Well, I'm getting there. My job was to get a on its own, right? And a is almost on its own. I just have this b hanging out in the back. So again, I'm going to bring down my next line. I'm going to rewrite what I have, and to get rid of a plus b, I'll do a negative b. But whatever I do to one side, I have to do to another. So I'm going to wedge in there, between my equal sign, a negative b. And so on my left-hand side, I have 2m minus b. And then over here, the plus b and the minus b cancel out. But that's what I wanted to do, right? I wanted to get rid of everything that was in the way of a. And now I can say a is equal to 2m minus b, right? Because that's what's over here. It doesn't matter which order I write these in, right? So I'll get everything to one side, so I got my a on its own. But then when I say it, I'll say a is equal to, this is equal to the other side. And this is how we manipulate formulas. We undo anything. We undo the operations. We do the opposite. If I'm dividing by 2, I multiply by 2. And that undoes it. And that leaves me with a plus b over here. And if I have a plus b, then I subtract by b, and that undoes it. But whatever I do to one side, I do to the other. And lo and behold, I've got a all on its own, which is what I wanted. So we can use formulas to hold things in little boxes, and then we can also manipulate formulas to get the thing that we want out in front. The other thing we can do with formulas is we can evaluate them. And by evaluating a formula, what we want to do is we want to put something we know into it so we get the thing we don't know out of it. And a good formula to look at, let's see, degrees Fahrenheit is equal to my degrees Celsius. Let's see if I have this right. I think, is it 5/9 degrees Celsius plus 32? Let's see. No, it's the other way around. It's 9/5. I always get that fraction backwards. 9/5 degrees Celsius plus 32. Well, what does this mean? What can we do with this? Well, if I know water freezes at 0 degrees Celsius, C equals 0. Well, what is that in Fahrenheit? So I come over to my formula, and wherever I see C, I drop in a 0. And so I drop in a 0. And 9/5 times 0 is 0. And 0 plus 32, water freezes at 32 degrees Fahrenheit. Well, water boils at sea level at 100 degrees Celsius. Well, what is that in Fahrenheit? So I come back to my formula. I'll rewrite it up here. And I go, okay, C equals 100. So I drop 100 into C. So 9/5 times 100 plus 32. Now this is a bit tricky. I have a multiplication and a division, if I think of a fraction as a division. So let me rewrite this as a multiplication and a division. Well, 100 divided by 5 is 20. So 9 times 20 plus 32. Well, that's 180 plus 32. or 212. And that is the temperature water boils at 212 degrees Fahrenheit. And so formulas are this thing we carry around. I carry around that Fahrenheit is equal to 9/5 the temperature in Celsius plus 32. And when I get a particular value, I drop it into my formula, and I get the answer I need. Sometimes I don't have the thing I want out front, and I can manipulate it so the thing I want comes out front. And we're going to be using formulas. We're going to start mostly with the evaluation type, where we'll give you numbers and you plug them into a formula to get the answer back out. But you'll sometimes need to rearrange them so that the thing you want to see is up front.